Hello, my beautiful viewers. You are welcome to my YouTube channel, Mathematics Made Easy. So, in today's video, we have this advanced calculus problem. So, it's not a sum and series, okay? So, we have sum of k from 0 to infinity of -1 raised to the power of k over k plus 2 raised to the power of s. We have to evaluate this. And then we have two additional questions to solve. Okay, so before we dive in, please don't forget to subscribe, like, comment, and share. Thanks guys for doing that. All right, solution. So let me write out the problem, so which is sum of k from 0 to infinity of -1 raised to the power of k, then over k plus 2, then raised to the power of s. So what do you think we can do? Now the first thing I'm gonna do now is to shift the index. So how do I shift the index? This is what we're gonna do. So we can say let n be equal to k plus 2. Okay, this is k plus 2. I don't want k plus 2 yes, I want a single function. Okay, so a single variable. Let me just say n. Okay, so if n is k plus 2, then this sum is gonna be in terms of n now, not k. Okay, and then check the sum. K starts from 0 to infinity, so let's input 0 here. So we're gonna have n equals 0 plus 2, so we're gonna have n equal to 2. Let's show that the sum will be starting from 2 now, not 0. And then if n is k plus 2, then we can make k the subject of the formula. So we can say k is equal to n minus 2. So anywhere you see k, you can just input n minus 2. All right, so if we do that, we're going to have the following. So we're going to have sum of n from 2 to infinity of -1 raised to the power of n minus 2, then over k plus 2, which is n minus 2 plus 2 raised to the power of s. So we're going to have sum of n from 2 to infinity of -1, then raised to the power of n minus 2, then over n raised to the power of s. Now, this is beautiful. This is actually beautiful. So what do you think we can do now? I want this sum right here to be in this form. So I want it to be in this form. Sum of n from 1 to infinity of -1 raised to the power of n over n raised to the power of s. Now, what do you think we can do here? Now, this is what I'm going to do. So I'm going to substitute, or I'm going to compute the values of n. N is starting from 2. So when it's 2, 2 minus 2 will give us 0. So that will be -1 raised to the power of 0, which is 1. Then that will be 1 over 2 raised to the power of s. We have 1 over 2 raised to the power of s. Then plus, when n is 3, that will be 3 minus 2, which is 1. Then -1 raised to the power of 1 is minus. So instead of plus here, we're going to have minus, okay? Not plus. So -1 over 3 raised to the power of s. The next one will be plus 1 over 4 raised to the power of s. The next one will be -1 over 5 raised to the power of s plus dot 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 minus dot 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 dot. We still have other terms, okay? Now, for this sum to be in this form, if you start substituting the values of n here, when n is 1, you're going to have -1. Okay, when n is 2, you're going to have plus 1 over 2 raised to the power of s. When n is 3, you're going to have -1 over 3 raised to the power of s plus dot 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 dot. So what you notice here, we lack -1 here for it to be in this form. Okay, so I'm going to subtract 1 and also add 1 so that we can make it balance. So if I subtract 1, I need to add 1. -1 plus 1 will give us 0. So it's not changing anything here. Okay, so we can now rewrite this sum right here as this. So which is sum of n from 1 to infinity -1 raised to the power of n over n raised to the power of s, then plus this one, don't forget, plus 1. Now, this is very beautiful. Very beautiful. Okay, so next thing we're gonna do now is to solve this sum. We're almost there because the sum is very easy to solve. So we have sum of n from 1 to infinity of -1 raised to the power of n over n raised to the power of s. Okay, I think that's the series. Yeah, beautiful. So this can also be equal to minus sum of n from 1 to infinity of minus 1 raised to the power of n minus 1 over n raised to the power of s. Yes, because minus 1 raised to the power of n minus 1 is equal to minus 1 raised to the power of n multiplied by minus 1 raised to the power of minus 1. And minus 1 raised to the power of minus 1 will give us minus 1. So this will be equal to minus 1 raised to the power of n multiplied by minus 1, which is minus into bracket minus 1 raised to the power of n. So we use it to multiply this minus, we are still going to have minus 1 raised to the power of n. So it's not changing anything there. Okay, it's just a matter of manipulations. Are we together? Now, remember or recall that sum of n from 1 to infinity of minus 1 raised to the power of n minus 1 over n raised to the power of s will give us eta of 2. Okay, that's eta function. So that's what is going to give us eta of 2. And then, sorry, eta of s. And we have a general formula for that, which is 1 minus 2 raised to the power of 1 minus s, then multiplied by zeta of s. Are we together? And don't forget this negative sign right here. So this will be equal to negative eta of s. Okay, then this will now be negative into bracket 1 minus 2 raised to the power of 1 minus s, then multiplied by zeta s. So if you open the bracket with a negative sign, you're going to have 2 raised to the power of 1 minus s minus 1, then multiply by zeta of s. So that is the sum. Okay, and don't forget we have plus 1 here. So if we add 1 to it, so we're gonna have, therefore we're gonna say sum of k from 0 to infinity of minus 1 raised to the power of k plus 2 raised to the power of s would be equal to 2 raised to the power of 1 minus s minus 1 multiplied by zeta s, then plus 1. Okay, so that would be the answer to that beautiful problem. All right, we have some additional problems. The first one, which is let's check. I'm going to solve the first one, then I'll leave the second one as an assignment for you guys to try. Okay, so minus 1 raised to the power of k plus 2 raised to the power of 2. So we have sum of k from 0 to infinity minus 1 raised to the power of k, then over k plus 2, then raised to the power of 2. All right, in this case, just set s to be 2. So if s is equal to 2, we're going to have 2 raised to the power of 1 minus 2 minus 1, then multiply by zeta of 2, then plus 1. So this would be 2 raised to the power of minus 1 minus 1 multiplied by zeta of 2 plus 1. So this would be, 2 raised to the power of minus 1 will give us 1 over 2. So we have 1 over 2 minus 1 multiplied by zeta of 2, then plus 1. And don't forget zeta of 2 is pi squared over 6. And 1 over 2 minus 1 will give us minus 1 over 2 multiplied by pi squared over 6 plus 1. Okay, 2 times 6 will give us 12. So you can bring 1 to the front self. So this will be 1 minus pi squared over 12. And that will be the answer to that beautiful sum. So I will leave the second question for you guys as an assignment. Try and comment the solution, comment the answer in the comment section. Thanks guys for watching. See you next time.